Hello there and welcome to integration using hyperbolic substitution. This is the second part of exercise 6e. It's a really long video. What I'm going to suggest we do is we break it up into small chunks. I'll do part of the video, you'll go and answer some questions, part of the video, go and answer some more questions, and we'll just repeat that until we get to the end of the video. The first set of questions I want to go through are these three questions here. They don't look like they need hyperbolics to be integrated, but they do. So let's get started on the first one, and just a reminder of what we know in terms of differentiation. Now, what do we know in terms of differentiation that might help our integration here? Well, we know that R shine differentiates to this expression here, which is exactly the same as question A. So this question here is probably going to involve shine in some shape or form. So what I'll do then is I'll start by a substitution. Integration by substitution is the order of the day here. I'm going to start by substituting x equals shine u. And whenever you do integration by substitution, it's really important you change the dx at the end as well. So differentiate what you've got here, multiply it onto the other side, the du onto the other side, and you'll have something to replace dx with, because not only does x need to be substituted, dx needs to be substituted as well. So let's put that all in then. It's going to be 1 over the square root of x squared, but that's going to be replaced with shine squared u plus 1, and then replace the dx with what dx is equal to as well, because that needs substituting as well. Cosh u du. Now what's going to happen next then? Well, recall that the identity for cosh squared and shine squared looks like this. It's shine squared u plus 1 equals cosh squared. So actually the whole of that thing under the square root can simplify to cosh squared u. So given that that thing can simplify to cosh squared u, this whole square root can now cancel out the square on that cosh. And then once that's cancelled out, we've just got cosh on the bottom, so that cosh here can cancel out with this cosh up here. And what have you actually got left? Well, you've actually only got left the 1 that's on top of this fraction. So it's just the integral of 1 with respect to u. Well, that's weird, isn't it? So that's simplified it so much that actually the answer to this question is just u, because that's the integral of 1 with respect to u plus c. Now we won't leave that as a final answer, because if the question is in terms of x, the answer must be in terms of x as well. So just remember that x was equal to shine u, and then if we inverse the shine on both sides there, it's now going to be r shine x equals u, so u is equal to r shine. So r shine x plus c is the answer to this question. And that was exactly what we had in the formula booklet right at the start there. The differential of r shine was this thing here, so it naturally does make sense that this thing here will integrate to r shine x plus c. We'll do something really similar with the next two questions as well. Let's just remind ourselves of what we have in the formula booklet, and we have that question B is the answer to the differential of r cosh. So it's probably going to be a cosh substitution for this question. So substituting x equals cosh u, then we need to work out what dx will be substituted with, so differentiate it and move the du onto the other side. Then let's substitute in both of those things. It's going to be 1 over x squared, and now that's going to be cosh u in this question, so the square root of cosh squared u minus 1 times what dx is substituted with, which is shine u du. Let's now simplify what we've got here. Reminder that the what we've got inside the square root on the bottom of that fraction will actually be simplified just to shine squared u. And once you've cancelled out the squared with the square root, you've just got shine u, which will cancel out exactly with the shine u on the side there. And all you'll be left with in this integral is just the 1 du. So what we can now do is integrate, that'll be u plus c. But we're not going to leave our final answer like that, because if x equals cosh u, then we can inverse the hyperbolic and have r cosh x equals u as the answer to this question. Okay, so this one will be r cosh, and that's very natural because the differential of it was the question. And the last one, let's have a look at that differentiation page. The question that we have here is the answer to the differential of artanch. So artanch is probably going to have something to do with my question, my way of working out the answer. So I'm going to use a tanh substitution for this question. So substituting x equals tanh u, we need something to replace the x with as well, so that's going to be sech squared, and then times the du onto the other side, and you've got what you need to replace the x with. This time when we substitute in, it's going to look like this, 1 over 1 minus tanh squared u times sech squared u. And then just a reminder of what we have in terms of a hyperbolic identity. If we take our cosh squared u minus sine squared u and divide it all by cosh squared, then we get 1 minus tanh squared u equals sech squared u. So the whole of that denominator now simplifies to sech squared u. That will cancel out exactly with what we have on the side of this integral, which is what we're multiplying by. So all we're left with here is just 1 du. Integrate the 1 and you get a u. Then we need to write the answer in terms of x. So just a reminder that x was equal to tanh u right at the start. Inverse the hyperbolic on both sides and you've got r tanh x equals u. So the answer to this question is r tanh x plus c, which makes natural sense because the differential of this was the question. But what happens then if you have something different than just 1 inside your integrals? Let's have a look at what we do. Okay, so for the first one, what we've seen here is that it's going to be something to do with a sine substitution, but we need to deal with this 4. So how can I introduce something extra onto the substitution to help that 4 cancel out? Well, because I'm eventually going to be squaring it, my substitution here is going to be x equals 2 sine u. Now why the 2? Well, because eventually we're going to be squaring that 2 as well as the sine function so that it will end up the same number as that 4. Notice here how I've got 4, 9 and 25 in my questions, and that's no coincidence that they are all square numbers here. So I'll differentiate that to work out what I need to replace dx with now, and then times the du onto the other side to get myself 2 cosh u. So let's now substitute in. And it's this big long thing here. We're going to have 1 over the square root, and it's going to be x squared. X was 2 sine u, so the 2 gets squared and the sine gets squared. And that's really nice because we've now got 4 here and 4 at the back there. So that's how we're going to sort out this 4. Then it's going to be times by dx, and dx has now been substituted with 2 cosh u du. So let's just remind ourselves that the identity is sine squared u plus 1 equals cosh squared u, and if we times all of that by 4, then we get 4 sine squared u plus 4 equals 4 cosh squared u. So underneath that square root then is going to appear 4 cosh squared u. Now when we do the square root of this, we can actually do the square root of these two components separately. The square root of 4 is 2, and the square root of cosh squared is cosh. So on the denominator here is just 2 cosh u now. And that will cancel out perfectly with the 2 cosh u that we have on the side. So we're back to that familiar position where we're just integrating 1 with respect to u. Do that and you get u plus c. And then just a reminder, it's going to be a little bit more tricky at the end here because we do have that 2. So x equals 2 sine u, divide by the 2, get rid of the sine, and it's going to be r sine x divided by 2 equals u. So the answer to this question here is r sine x divided by 2 plus c. So just a little bit different to previously when we had x squared plus 1. It's now going to be r sine x over 2. And that's what happens. That's how you're going to deal with it when you've got a different number being added, subtracted into the square root. Let's move on to the next one then. And this one here is going to be a cosh substitution by my familiar integrals or differentials in the formula booklet. This time it's a 9, so how am I going to square something so that it can cancel out with a 9? Well, it's probably going to be 3, so it'll probably be 3 cosh u that would be the substitution for this question. Then we need to work out what dx will be substituted with, and that's going to be 3 sine u du. It's very similar to the previous question, so we'll substitute it in. It's going to be 1 over x squared, but x here is 3 cosh u, so the 3 gets squared and the cosh gets squared to 9 cosh squared u minus 9. There we perfectly have it, the 9's match up. Then we need to remind ourselves that cosh squared u minus 1 is equal to sine squared u, so we'll times everything through by 9, and that square root, the value inside that square root is now 9 sine squared u. Then on the side it's going to be times by 3 sine u du. And eventually what will happen is when you've done enough simplifying, these two expressions here will cancel each other out, back to that same position of 1 du. Do your integration, you get u plus c, and then a reminder that x was equal to 3 cosh u to start with. So rearranging this to work out u as the subject, divide by 3, get rid of the cosh or inverse the cosh, and you get r cosh x over 3 equals u. So the answer to this question here is r cosh x over 3 plus c. And there we are. And let's have a go at the final one then. So it's going to be 25 minus x squared. This is the tanh integration by substitution style question. This time I'll use a 5 because it's when I square it, it will help cancel out that 25. So when I work out what dx needs to be substituted with, I'll differentiate the substitution and times du onto the other side and get 5 sec squared u du. So when I substitute in x, I get 1 over 25 minus 25 tanh squared u times the substitution for dx, 5 sec squared u du. And when this gets simplified out, just a reminder that how do we simplify this denominator? Cosh squared u minus sine squared u equals 1. Divide everything by cosh squared, and you get 1 minus tanh squared u equals sec squared u. Then you can times it all by 25, and you've now got 25 sec squared u on the bottom. But hold on, this isn't going to simplify out perfectly. Well, the sec squareds will, but the 5's won't. You'll cancel out this 5 with one of these factors of 5 from the bottom, and you'll be left with 1 over 5 as the thing you need to integrate, which does make a nice polite change actually, if you don't mind me saying so. Integrating 1 was getting quite boring. I'll now integrate 1 over 5. So integrating 1 over 5, well, it's easy. 1 over 5 u plus c. Just a reminder of what u was. X was equal to 5 tan u, so divide by the 5 and inverse the tanh, and you get r tanh of x divided by 5 equals u. So there's their answer. Slightly different to what we've seen before. Usually it's just the divide by 5 in the brackets, but with r tanh we have to divide by 5 at the front as well. So it's 1 over 5 r tanh x over 5 as the answer here. And you get actually all of this stuff here in the formula booklet as well. So actually next time you come to doing a question of this style, you can just use the formula booklet, but sometimes what I've seen in exams is they particularly want you to do it by the method of integration by substitution, and they'll say do this by integration by method of substitution, and you can't just use this formula booklet. But if you're stuck inside the context of a question, definitely use these formulas here. What do we have? Well, the second question, question B here, corresponds to what we have in the formula booklet here. This was A corresponding to the value of 3, so A was the value 3 in our answer for the integral. Question A corresponded to this little bit here in the formula booklet, where A here corresponded to the value 2, because it's 2 squared is 4 inside your integral, so it's r sine x divided by 2. And then with the last one, it's this corresponding with this term here. A was representing the number 5 in this formula, so it's 1 over 5 r tanh x over 5. This bit in the middle is if you were to decide to do this question by integrating by partial fractions instead, but don't worry about this bit in the middle, go straight to this bit on the end, and it's 1 over 5 r tanh x over 5. So we get this in the formula booklet. So now in the subsequent questions that I'm going to do, I'm going to be referring to this formula booklet over and over again. I'm not going to always do it by substitution, but it's really important that you know that that's where these formulas come from. It's by substitution, just in case you are asked in the context of, in case you are asked explicitly in a question, do this by integration by substitution, you now know what to do. Oh yeah, just highlighted all of them. Alright then, so what I suggest you do now is pause the video and have a go at questions from page 140, questions 11a and 12a and b. I'm now going to carry on, but I really encourage you to pause it and have a go at those 3 questions. Okay, so let's move on to the next section. We're going to make these questions slightly harder than the ones we've seen before, but still using the same ideas and the same area in the formula booklet. So this is the integral of 1 over the square root of 3x squared plus 27, and really we'd like to get rid of this 3 in front of the x squared to be able to use the formulas from the formula booklet. So if that's what we'll do, we'll just factor out the root 3 from the denominator, and it'll be 1 over root 3 at the front of the integral, and then the integral of 1 over the square root of x squared plus 9, factorising the 3 out from 3x squared and the 27, so it's x squared plus 9. And now we just need to use the correct part of the formula booklet. So let's go to it. We're going to be going down to the 1 over square root of x squared plus a squared. So it's going to be this second one from the bottom here. It's going to be an r shine answer. So here a is going to be 3 because it's 9 inside the integral, which is matching up with the a squared. So here a is equal to 3. So in the answer, it's going to be r shine x over 3. So it's going to still have that 1 over root 3 at the start, and then the answer is r shine x over 3 plus c. And there we are. We've effectively used integration by substitution from the formula booklet. So there we are. That's the answer. Let's move on to, in fact, we could even get you to pause and have a go at this set of questions here. Page 141, questions 11b, 13a and b, 14, 15a and b. Make sure you pause the video now, have a go at those, and then I can show you how to do the rest of the questions from the exercise in these exercises here. So moving on to the next one, it's x squared minus 6x, and in this question you need to complete the square of the quadratic inside the square root, mostly because there is an x attached to this 6. If there was no x attached to this 6, you could just use the formula booklet straight away, but you do have to because there's an x here. So we're going to complete the square to x minus 3 squared minus 9. Then we're going to do a small substitution, which won't really affect too much, and then use the formula booklet for the bigger substitution. So really this x minus 3, it'd be lovely if we could just make that a little bit more simpler. So we're going to be replacing x minus 3 with u. And what will dx have to be substituted with? Well, actually, when you do the differentiation on the substitution, dx is equal to du. If you had any limits, you'd have to reduce all of your limits by 3. But there's no need to change the letter here. In fact, I could just scribble that x out and put a u next to it. So it's going to be 1 over u squared minus 9. And now we can use the formula booklet. So let's go to that formula booklet. Which integral are we going to be using? It's going to be this one here, where it's x squared minus a squared. And again here, a matches up with 3. A squared matches up with 9. So a here is equal to 3. So it's going to be r cosh u over 3 plus c, but in our question, the question had x in it, so we need our answer to have x in it, so we need to now bring in that substitution again, so u being substituted back in with x minus 3, so the answer here to this question is r cosh x minus 3 over 3 plus c. So there we are. We had to do a little baby substitution at this stage here, just to replace the x minus 3 squared, because we had to complete the square where there is a 6x right at the start of the question. Okay, let's move on to the next part now, and once again we're going to be completing the square of this more complicated quadratic on the denominator. So complete the square of this, and you will get 16 minus x plus 3 squared. And the next thing to do will be to do that little baby substitution of the x plus 3 being replaced with u. Eventually dx will be the same as du, so no need to really replace that. So it will now be 1 minus 16 minus u squared, so 1 divided by 16 minus u squared. Go to the formula booklet, And which integral are we going to be using here? It will be this bottom one. It will be no square root involved. It would be just 1 over a squared, and a squared will have to match up with the 16 here, so a will be 4. So the answer is going to be 1 over 4 r tanh x over 4, or u over 4 rather, because we were integrating with u here. We're integrating with u here, so therefore we need to now bring x back in through that u. So the actual answer to this question is going to be 1/4 r tanh x plus 3 over 4 plus c. And let's move on to the final one out of this set of examples. It's going to be 1 over 12x plus 2x squared. What are we going to do here? First, we're going to factorize out the root 2. So it'll now be just 6x plus x squared. Then we complete the square of the expression inside the square root. So it'd be this thing here. Do the baby substitution of x plus 3 to replace it with a u. And that won't really affect the dx at all, because when you differentiate, dx by du equals 1. So dx equals du. So we've got that 1 over root 2 still hanging on at the front. Then the integral of 1 over u squared minus 9. Grab your formula booklet. Which integral are we going to be using here? It'd be the Cosh one, because it's got a minus a squared or a minus 9. So here a must be matching up with 3. So it's going to be 1 over root 2 r Cosh u, because it was a u integral here, u over 3 plus c. Then bring the u back in for x plus 3. So it's going to be 1 over root 2, no, not 1 over 4, 1 over root 2 r Cosh x plus 3 over 3 plus c. And there we are. That's the answer to part D. What I want you to do now is have a go at the questions from page 141, questions 21 to 25, just so we're breaking this video up into smaller chunks, with you giving yourself a chance to consolidate what you've learnt at each interval. Right, these 3 questions will be the final questions we'll go through in this video then. So the first one is going to be the integral of the square root of 1 plus x squared dx. So what I think would be a good idea is we need to use a substitution of some kind for this question. Let's use the formula booklet to give ourselves a hint. On the second to bottom row, we can see something very similar to what we want to integrate. There's no 1 over involved, but it's going to involve something probably to do with shine. So let's pick shine as our substitution. So we'll replace x with shine u, and we will know that 1 plus shine squared u will simplify to Cosh squared u. So that should be fine. It should simplify for us. We need to work out what dx will be replaced with. So differentiate your substitution times by du, and we're going to get dx equals Cosh u du. So let's now substitute both of those expressions in. X goes in as shine u, and dx goes in as Cosh u du. Let's now simplify what we've got. So we need to remember the identity inside the square root, which will simplify it to Cosh squared. And then the square and the square root will cancel each other out. So we've just got Cosh for this part here, Cosh for the second part here, and now we've got Cosh squared. Then we need to remember how to integrate Cosh squared. Well, we do that through the double angle formula identity, just like we do with cos squared. So the identity just rearranged is going to be a half Cosh 2u to x plus 1, or in this case it will be 2u. So a half integral of Cosh 2u plus 1 du is our integral. So let's go ahead now and do that integration. The 2 will divide to the front, Cosh will integrate to shine, and 2u will stay the same. 1 will also integrate to u. Now we need to get this back in terms of x. So the first part, the shine 2u, just a reminder, will be 2 shine u Cosh u. That's fine for the first part because that shine u will just turn back into x. But what about Cosh u? So the shine u will turn back into x, and then also remember that cosh squared u minus sine squared u is equal to 1, so that we can work out what to do with this cosh. If we move the sine onto the other side in square root, then cosh u, this bit here that we want to replace with an x, will be replaced now with 1 plus x squared square rooted, because cosh u is equal to the square root of 1 plus sine squared u, so replace the sine with the x it's equivalent to in this question, and you've got 1 plus x squared square rooted. So the first part is fine, it's going to be a half. Sine u is x, so that will be replaced with an x, and then this cosh u will be replaced with this square root thing. And the second part here will be plus half u, just a reminder that x is equal to sine u, inverse the sine onto the other side and you get u equals r sine x. So this expression here will just be replaced with half r sine x plus c. So there we are. This is the combined answer for the first part. Quite a tricky integral, this one, where we have to remind ourselves of some integration through a double angle formula, and then how we write cosh u back in terms of sine so that we can write it in terms of x as well. Okay, so that's the answer to the first part. Pretty tricky, that one. Second one is an integral between two boundaries of 6 and 0. So let's remind ourselves of how we do that. But let's first of all think about what substitution we're going to use for this question. It's always helpful to have a little look at the formula book. Let's see what they suggest. And on the denominator of the second to last term, again, we have a squared plus x squared. And this one is x squared plus 9. So it seems sensible that we'll put a as 3 and then integrate with a sine substitution. So it'll probably be 3 sine u as our substitution for x, and there we are. Do your differentiation to work out what dx is going to be replaced with, and dx is going to be replaced with 3 cosh u du. But we also need to work out what 6 and 0 are now going to turn into, because 6 is the x upper limit, so 6 will be the x upper limit, will be equal to 3 sine u. So that will mean that sine u is equal to 2, and then inverse the sine, so u is going to equal the inverse sine of 2. So that will be the upper limit. The lower limit of x is 0, so if 0 equals 3 sine u, well, u is equal to 0, because r sine 0 is 0. So the new limits here are going to be r sine of 2 and 0 on the bottom. Then we need to do the substitution, so it will be x cubed on the top, and if x is equal to 3 sine u, it's going to be 27 sine cubed u, over the square root of x squared. X is 3 sine u, so that would be 9 sine squared u plus 9. That's really helpful that we have 9s on the bottom there. And then the dx is going to be replaced with 3 cosh u du, so it's times 3 cosh u du. Let's now simplify what we've got here, and the whole of that denominator will cancel out with this bit on the side here. So we're left with the 27 that will factorise out to the front, integral of r sine 2 to 0 of sine cubed u. Now we saw this in the previous video, how to integrate this. You split it up into a sine squared u and a sine u, then use the cosh squared u minus 1 identity to replace the sine squared u, times it by sine u, expand the brackets, and then this first part here, you can either do it by an integration by substitution, u equals we'll do it v equals cosh u will be a good substitution to do this, and then the sine u will just integrate cosh u. So we're at this bit here, and we've integrated. I'm not going to do this bit here, but trust me, the answer is 1 over 3 cosh cubed u. I expect you to be able to do this by now. If you can't, then go back to the previous section, have a go there. But you do an integration of cosh u, v equals cosh u, and you get this expression here. And then minus sine u to cosh u. Now, what we have to do is we now have to substitute in r sine 2. Oh, it's not working very well because we're going to have to be substituting into a cosh rather than a sine. So what we're going to have to do then is we're going to have to remember what work we've previously done with our substitution, and we know that here x is equal to 3 sine u. Or in fact, what we got to was this bit here where we said that 2 was equal to sine u. We also know, just from the identity, that cosh squared u is equal to sine squared u plus 1. Square root both sides, and you've got now what cosh u is equal to in terms of sine u. So sine u is equal to 2, so we'll put 2 in for sine u, and we're going to get that cosh u is equal to 2 squared plus 1 all square rooted, which is root 5. So now I know that cosh u is equal to root 5 when you substitute in r sine u, r sine 2. So when I substitute in cosh u being root 5, I get this expression here. It's going to be 1 over 3, and then it's going to be root 5 cubed, which will leave me with 5 root 5, minus cosh u, which is root 5. Then I'll substitute in 0, so it's going to be a third times cosh of 0. Cosh of 0 is 1, so it's going to be a third of 1 minus 1, because cosh of 0 is 1, and then the 2 terms subtracted. And then once you've worked each of these individual components out and simplified it in your calculator, you get the final answer of 18 root 5 plus 18. So there we are. That's the answer for that question there. Quite a lot in that question there. We had to decide on the substitution. We had to work out that what cosh u was when r sine was 2, etc, etc. So pretty tricky question, that one. What I suggest you now do is have a go at page 141, questions 16 to 20, before I do the final question, and we move on to the final question where you have a go at the end. So we're breaking the video down into smaller components here. Have a go at these 5 questions, then come back to the video and we'll have a go at question C together. And the final question here we'll go through now is question C. Now what we could do with this question, and what you've seen in previous questions, is to take out as a factor this 4, because it's multiplying onto the x squared. In fact, what's easier, if you try that, it'll actually end up with some very complicated numbers, and you'll have fractions of fractions, which isn't very nice at all. What I suggest we do instead is we actually complete the square from this expression here. So complete the square, and what you'll get is 1 over, and it will nicely turn into the square root of 2x minus 3 squared minus 16. We'll do that baby substitution of 2x minus 3 being substituted with u, and then what we'll get there is for the dx to be substituted as well, is when we differentiate it, we'll get du by dx equals 2, and then we'll times the dx onto the other side and divide by the 2, so we get dx equals a half du. So substitute the u into the 2x minus 3 and replace the dx with a half du, and this is what we'll get. Just tidy it up a little bit, put the half at the front of the integral, that's always helpful to do that, and then go for your formula booklets. The formula booklet probably suggesting you use the Cosh formula there, and I think a will be equal to 4 here because it's minus 16, which is corresponding to a squared, so a is equal to 4 here. So it's going to be a half r cosh u over 4, because that's the value of a plus c. And then the final thing we need to do is bring x back in, because x is equal to, well, u is equal to 2x minus 3. So the answer for this question is a half r cosh 2x minus 3 divided by 4 plus c. And there we are. That's the answer to this final question. Your turn to have a go at question 16 if you haven't already done so. I'm going to go through it in a second here. I've chosen it as it's a particularly challenging question. Pause the video and give this one a go. Okay, so in this question it suggests us to use the substitution of x equals sine squared u for this integral. So let's go ahead and do that. Before we do that, however, it's probably a good idea to work out what dx is going to be substituted with. So dx by du is going to be equal to sine u cosh u. So dx is going to be substituted with 2 sine u cosh u times by du. So let's now work out what this integral is going to be. It's going to be the integral of the square root of x, which is equal to sine squared u, over sine squared u plus 1 times by, I'll put the 2 at the front, sine u cosh u du. Alright, so let's work out what this is going to simplify to then. If we've got sine squared over, this will be cosh squared, so it's going to be sine squared over cosh squared, which is tanh squared, so it's going to be tanh here. Then it's just going to multiply by sine u and cosh u. Now remember, tanh is sine over cosh, so actually I'm going to cancel out the cosh here and inside the tanh to leave us just with sine squared u du. So now we're integrating sine squared. The way that we do this is with the identity, the Cosh double angle identity, cosh 2u is equal to, it's going to be 1 plus 2 sine squared u. So eventually when we come around to rearranging this, the 2 and that half will cancel out, so it's going to be cosh 2u minus 1 du. The half and the 2 will cancel each other out. Then let's do the integration, so it's going to be 1 over 2 sine 2u, and then it's going to be minus u plus c. Right, okay, that's only the half of the story, because what we now need to do is we now need to write this back in terms of x. So it's going to be 1 over 2, but if we're using the sine double angle formula, that half is going to cancel out because it will be a 2. So it's going to be sine u cosh u minus u plus c. Okay, so this sine will be pretty straightforward because that would just be the square root of x. Cosh u, let's just write it down here just so I've got it nice and clear. Cosh squared u is equal to 1 plus sine squared u. So if I just want to know what cosh is, so if it's square root of 1 plus sine squared, then it's going to be the square root of 1 plus x, because it's sine squared is x, so it's 1 plus x, so there we are. And the final part is u, so we square root the x and then inverse the sine, so it's going to be minus r sine root x plus c. And there we are, that's the answer for this question here. So that's a pretty long one there. So hopefully you found that video helpful. Hopefully you have broken down the video into smaller chunks and done the questions in the portions that I've suggested. If not, then feel free to go back and do that exactly that way. So there we are, that's the answers, that's the run through for exercise 6E. Hopefully you found that video helpful, and thanks very much for watching.